Hello everyone, my name is Hemant and in today's video we are going to discuss part test 9 mathematics paper. So let's begin. Here is the first question. Question number 51 says integration of x e power x divided by 1 plus x whole square dx. So here what we can do is let's write e power x separately and whatever is the numerator remaining, that is x, can I write it as 1 plus x minus 1? The moment you write it as 1 plus x minus 1, you can see that the denominator part can now be separated and written as e power x divided by 1 by 1 plus x minus 1 by 1 plus x whole square dx. Now using this property, using e power x integration fx plus f dash of x dx equals to e power x fx plus some constant c, can I say that the answer for this integral will be e power x divided by 1 plus x plus some constant c? Because if you observe the differentiation of this part 1 by 1 plus x is basically minus 1 by 1 plus x whole square. So this is the given function here, and this f dash of x with its negative sign you can observe there. So clearly using this result we can say that option number D is correct. Question number 52 is again e power x and we are having sine 2x minus 2 divided by 1 minus cos 2x dx, and if you observe I can write sine 2x as 2 sin x cos x minus 2 divided by 1 minus, in place of cos 2x we can substitute 1 minus 2 sine square x, right? 1 minus 2 sine square x dx. So using this substitutions in place of sine 2x and cos 2x, we can write this as e power x. Now I can write this as 2 sin x cos x divided by, denominator part will be only 2 sine square x because 1 and minus 1 will get cancelled. So this is 2 sine square x and then again minus 2 divided by 2 sine square x dx. So if you observe, this 2 and 2 is getting cancelled, here also 2 and 2 is getting cancelled, one sine will also get cancelled, cos by sine will be cot x minus cosec square x. So again this is the same property that we observed in the first question. It is integration of e power x, this cot x is the function and minus cosec square x is its derivative. So answer will be e power x cot x plus constant c. Option D is the right answer. Question number 53 says integral minus pi by 2 to pi by 2 cos power 6x dx. So if you observe, this is an even function, so I can write this as 2 0 to pi by 2 cos power 6x dx. Now we have a result to solve this kind of 0 to pi by 2 sine power mx or cos power some nx dx. So the formula by which we can give this result is basically based on Wallis formula. Okay, so from there we can write this as whatever is the power on cos, we start writing one number less than that, so it will become 5, and then at a difference of 2 we write till we reach 1, or basically we should not write 0 and all, we have to reach till the last number. In denominator we start writing with the same power as it is, so 6, and then again the difference of 2 in the denominator 4 and 2, and whenever we have at the end 2, definitely we don't have to go till 0, we have to stop at 1 or 2, so wherever it is 2 we multiply with pi by 2 here. So this much portion of integration basically will be 2 into, and let's simplify this, it is 15 pi, and in the denominator we have 6 into 4 which is 24, and we have 2 into 2 4, so it is 15 pi divided by 48, because this 2 will also divide this, so it is 15 pi by 48. If you further divide by 3, we'll be getting 5 pi by 16, which is option C. Question number 54 is integration dx by sin x plus root 3 cos x. So let's multiply this denominator by 2 and also divide. So we have 1 by 2 sin x plus root 3 by 2 cos x. Now in place of 1 by 2, if I write cos pi by 3, I can write this root 3 by 2 as sin pi by 3. Then it will be a formula of sin A plus B. So we can say that it is 1 by 2 dx divided by sin x plus pi by 3, which is basically 1 by 2 cosec x plus pi by 3 dx. Now the integral of cosec x dx is basically ln tan x by 2 plus constant c. This is the formula. There is one more formula for integration of cosec x dx, that is log of cosec x minus cot x. If you simplify that, you will get this also. So if we apply here, it will be 1 by 2 ln or log mod of tan. Here it is cosec x plus pi by 3. So we have to write tan of half of this angle. So it will become x by 2 plus pi by 6 basically, and plus some constant c. So if we observe, it is option number B, 1 by 2 log tan x by 2 plus pi by 6 plus some constant c. Question number 5 is the degree of the differential equation x equal to dy by dx minus dy by dx whole square by 2 plus dy by dx whole cube by 3 and so on is. So this question is based on a very interesting expansion that you already study in limits log 1 plus x. This expansion is x minus x square by 2 plus x cube by 3, then minus x power 4 by 4 and so on. So if you observe, in place of x in our given differential equation, in place of x it is dy by dx basically. So I can say that this entire thing I can write as x is equal to log of 1 plus dy by dx. And if I am able to write the differential equation in this format, I can also define its degree once I convert this in a format of e power x. So this will be e power x equal to 1 plus dy by dx. So if you observe, this is a differential equation with order 1 and degree also 1. So option number D is correct. Question number 56 is area in square units of the region outside mod of x by 2 plus mod of y by 3 equal to 1 and inside the ellipse x square by 4 plus y square by 9 equal to 1. So if you observe, this is a square value which is 4 and this is b square value which is 9, which means a is 2 and b is, let's suppose, 3. Then we can draw the diagram for the ellipse and that will be something like this. Okay, let me draw it little bit properly. This is a rough sketch of the ellipse. Let's suppose this is a 2 comma 0 and this will be b which is 3 comma 0. Now if you observe the given line, it is mod x by 2 plus mod y by 3 equal to 1. Let's suppose if there is no mod in the given expression, it is only x by 2 plus y by 3 equal to 1. That means the x coordinate or x intercept basically, not coordinate, x intercept is 2 and y intercept is 3, which means the line would have passed like this, passing from A and B. Same way, there are multiple possibilities. When x is negative, y is positive, the diagram of this same line will be something like this. Similar way, if x and y both are negative, then in that case the line equation will be like this. And the last case, if x is positive, y is negative, in that case it will be passing like this. So it is basically formation of a quadrilateral, and that is also basically a rhombus. And if you observe, they said that the region outside of these lines and inside of the ellipse, it means they are asking about this area, this remaining area everywhere. Okay, so how can we find this? We know that ellipse area is pi AB, so that will be pi into 2 into 3, which is 6 pi, From that we need to subtract this triangle areas. So one triangle area, if I find out, let's suppose this is A1, it is 1 by 2 into 2 into 3, so it is 3. So 4 times of A1 will be 12. So I can say that the actual area is, required area is 6 pi minus 12. So if I take 6 common, it will be pi minus 2. 6 into pi minus 2, which is option number C. Question number 57 is, the population at a time t of a certain species follows the differential equation dp by dt equal to 0.5 p minus 450. If p0 is 850, then time at which population becomes 0 is. So this is a very simple differential equation where we can write dp by dt as half p minus 450. I can write this as p minus 900 by 2. P minus 900 by 2. Now I will separate the variables. dp by p minus 900 is equal to dt by 2. Now just integrate this. It will be ln p minus 900 equal to t by 2 plus some constant c. Okay. Now some boundary conditions are given to find out this constant c, and that is at t equal to 0, population is 850. So I can say it is ln 850 minus 900 and time t is 0, so this will be 0 plus some constant c. So I can say the constant value c will be equal to ln 50 because there is a modulus sign after ln. So ln 50 is the constant value. Now I can say that the actual equation is ln p minus 900 equal to t by 2 plus ln 50. Population has to be 0. In that case, I can say it is ln 900 equal to t by 2 plus ln 50. It means I can say t by 2 is equal to ln 900 minus ln 50, which is ln 900 divided by 50. So it will be 900 by 50, which means 0 0 cancelled, and it is ln 18. So time will be 2 times of ln 18, which is option number D. Question number 58 is, the differential equation representing the family of curves y square is equal to root over c x plus 2c, where c is a positive parameter, is of order and degree. So if you observe, the given equation is y square equal to root over c x plus 2 times of c, and we can differentiate this and write 2y dy by dx, that is equal to root over c. Now we can replace from this first equation and second equation. Let us try to replace this arbitrary constant. So I can say y square is equal to, instead of root c, I can write 2y dy by dx, and then I can write x plus 2 times of, in place of c I will square this second equation and write 4y square dy by dx whole square. So in that way there is no arbitrary constant remaining in the equation. So I can easily say that order is equal to 1 because I can only observe dy by dx. And what about the degree? Degree is the highest power on the highest order derivative. So you can see there is a dy by dx here. It will go inside and multiply with this, so it will be dy by dx power 3. So order is 1 and degree is 3. Option C is correct. Question number 59 is, integration dx divided by, we have x minus 1 cube and x plus 2 power 5, and then whole to the power 1 by 4 basically. X minus 1 cube, then we have x plus 2 power 5, and then entire thing we are having power as 1 by 4. So it means the question is dx by x minus 1 power 3 by 4 and x plus 2 also we are having power 5 by 4. So we can write the entire expression as dx by x minus 1 by x plus 2 power 3 by 4. Okay, and since we have introduced x plus 2 power 3 by 4 in the denominator, we have to introduce it in the numerator also. But already 5 by 4 was there, so 3 by 4 and 5 by 4 together it will give 8 by 4 and it will become 2. So x plus 2 whole square will come here. Now you make a substitution, which is x minus 1 by x plus 2 equal to t. X minus 1 by x plus 2 equal to t. And let's differentiate. So differentiation of left side will be x plus 2 whole square. Numerator differentiation will be 1. Denominator will be as it is. Then minus. This time numerator will be as it is. Denominator differentiation will be 1. And dx equal to dt. So if you observe, it will be 2 plus 1 we will be left with 3 dx. Okay, 3 dx by x plus 2 whole square equal to dt. So now this integration can be written as, if I write 1 by 3, then I will be able to write 3 dx in the numerator, and in place of 3 dx by x plus 2 whole square, I will be able to write dt, and this will become t power 3 by 4, which is basically 1 by 3 integration of t power minus 3 by 4 dt. So finally I can say answer will be 1 by 3 t power minus 3 by 4 plus 1 will be 1 by 4, and same 1 by 4 will be in the division also. So it is 4 by 3 t power 1 by 4 means x minus 1 by x plus 2 power 1 by 4 plus some constant c at the end. So answer will be definitely option number C. Question number 60 is, if x is equal to xy is the solution of the differential equation y dx by dy is equal to 2x plus y cube into y plus 1 ey, x1 equal to 0, then xe is equal to. So let's write the given question once more properly. Y dx by dy is given as 2x plus y cube y plus 1 e power y. Okay. Now let's divide this entire equation by y. We'll be getting dx by dy, then 2x by y, then this will be y square y plus 1 e power y. Now I can transfer 2x by y to the left side. It will become 2x minus 2x by y basically, and that is equal to, we are left with y square y plus 1 e power y. Alright, so if we compare this with dx by dy plus px equal to q, p value is minus 2 by y and q value is this entire thing. So integration factor will be e power integration p dy, which is basically e power integration minus 2 by y dy, which is integration will be minus 2 ln y. Okay, and this minus 2 can go on the top of y as power, so it is basically y power minus 2. So we have got the integration factor. Now to get the solution, we have to write x into integration factor, then integration of q into integration factor dy. So x into integration factor will become 1 by y square, and here we can write q, which is y square into y plus 1 into e power y into integration factor 1 by y square. So this is cancelled straight away, dy. Now integration of e power y plus 1 is basically e power y into y plus some integration constant. So I can write from here x is equal to y cube e power y plus cy square. To get the constant value, they have given a condition that x1 is equal to 0. It means 0 is equal to 1 cube e power 1 plus c into 1 square. So from here I can get the c value as minus e. So overall the function is x is equal to y cube e power y and then minus e y square. So at x equal to e, I mean x e value, if you want to find, you have to put y equal to e, which will be e cube and then e power e, then minus e into again e square. So I can take e cube common, it will be e power e minus 1, which is option A. Question number 61 is, there is a function fx equal to a sine pi into greatest integer x by 2 plus greatest integer of 2 minus x, and if limit x tending to minus 1 fx exists, then the value of integration 0 to 4 fx dx is. So for this limit to exist, we have a condition, left hand limit should be equal to right hand limit at x equal to minus 1. So if you take any value less than minus 1 in the greatest integer, it will give you answer as minus 2 basically, and minus 2 by 2 it will become minus 1. So it's basically a sine minus pi, and since in the other box or in the other greatest integer function we are getting 2 minus at x value less than minus 1, let's suppose you are putting minus of 1.5, then it will become plus 1.5 and it will be 3.5 whose greatest integer is 3 only. So you will be left with 3 here directly. So I can write 3, and meanwhile this sine minus pi is becoming 0. So left side you will be left with 3 as the answer, and on right side let us see what is happening. The right side, it is a times sine of if I am taking any value other than -1 and little bit more than -1, then its greatest integer value will be -1 itself. So it will be minus pi by 2. And for analyzing this second term 2 minus x, let's suppose you are putting a value minus 0.99, which is very close to -1 but on the right side. So this will become 2.99, whose greatest integer is basically 2. So it will be directly 2 here. So sine minus pi by 2 is actually -1. So minus a plus 2 is 3. So a value is coming out to be -1. So now we can go to the calculation of integration basically. So integration is actually 0 to 4 fx dx, and fx we are sure about that now because we have calculated the a value. It is -1, so there will be a minus sign before sine. Pi times integer x divided by 2 and plus greatest integer of 2 minus x dx. Now this entire thing can be split into 0 to 1, then 1 to 2, then 2 to 3 and 3 to 4 because of the presence of this greatest integer x. Now let's try to understand the values of this entire function in each of the limit. Suppose 0 to 1 you take any value 0.5. 0.5 greatest integer is 0, sine 0 is 0. Then 2 minus 0.5 is 1.5, whose greatest integer is 1. So there will be only one term, which is 1 dx, plus next one 1 to 2 you put any value, suppose 1.5. Its greatest integer value will be 1 only. So sine pi by 2 is 1 and there is a minus sign before it, so it will be -1. Now let's see the second term also. 1 to 2 you put any value, let's suppose 1.5. So 2 minus 1.5 is 0.5. 0.5 greatest integer is 0, so therefore there is no other term. In 2 to 3, let's suppose you are putting 2.5 to understand the function value. 2.5 greatest integer will be 2, so 2 and 2 will get cancelled, sine pi will be remaining, so first term will be 0. And 2 minus 2.5 is giving you minus of 0.5, which is having greatest integer as -1. So this time again there will be -1 dx. 3 to 4, what will happen? If you put 3 to 4 any value, it will be sine 3 pi by 2, which is -1, and there is already a minus sign, it will become 1. And 3 to 4, this 2 minus x, 2 minus x means, let's suppose you are putting 3.5. So 2 minus 3.5 is -1.5, whose greatest integer value is -2. So I can write 1 minus 2 dx. So overall this is 1, this is -1, this is -1, and at last if you observe, after adding, already it is 1 minus 2, so it will give minus as the answer. Being cancelled, at last we are left with 2 minus 1s, which will together give answer as -2. Question number 62 is the area of the smaller region enclosed by the curves y square is equal to 8x plus 4 and x square plus y square plus 4 root 3x minus 4 equal to 0 is equal to. So let's understand the question by drawing the rough sketches of the each of the curves. So let's draw the parabola. Parabola, if you observe, is y square is equal to, if I take 8 common, it will be x plus half, which means the vertex is at -half. So the graph of parabola will be something like this. Let me draw it more clearly. So it will be something like symmetric about x-axis and vertex at -half. So this is -half comma 0. Now there is a circle whose center coordinate, if you observe, is basically -2 root 3 comma 0. If you divide the x coefficient by -2 and y coefficient by -2, directly we get the center coordinate of the circle in this general form. So if you see, -2 root 3 will be somewhere here, which is C, which is the center point. And if you observe the radius of the circle, that is given by square of the coordinates of the center, you can write as sum. So it will be 4 into 3, 12 plus 0 and then minus of the constant term. So it is basically root 16, that is 4. So 2 root 3, if you observe in terms of value, it is 1.732, which is 4, 6 and 3.464. So basically on the minus side, it is somewhere around -3.464. So the circumference of the circle will basically cross the y-axis, and if I draw the rough sketch, it will be something like this. Now for point of intersection, I can substitute y square is equal to 8x plus 4 in the circle equation. So it will become x square plus 8x plus 4 plus 4 root 3x minus 4 equal to 0. 4 minus 4 getting cancelled. I can take x common. It will be x plus 8 plus 4 root 3, that is equal to 0. So we are getting two values of x. One is x equal to 0, other one is minus 8 minus 4 root 3. But this value is not possible, as you can see from the diagram. Okay, since y square curve is opening towards the right. So we are having x equal to 0 as the only possible coordinate. So at x equal to 0, we will be getting y square is equal to 4, which means y is equal to 2 or minus 2. Both values are possible, and we can see that that's what we have got as two intersection points. And the smaller region is this one only. So this shaded portion we need to find out. We can find out the area just above the x-axis, and then we can multiply with 2. Area calculation, let's also write down the circle equation in a central form. It will be x plus 2 root 3 whole square plus y square is equal to, the radius was 4, so it is 16 square. So I can say it is x plus 2 root 3 is equal to root of 16 minus y square, and then x is equal to root over 16 minus y square minus 2 root 3. And the curve for the parabola, if you want to write x expression, it will be y square minus 4 by 8. So the area will be equal to 2 times integration from 0 to 2. These are the limits of basically y. So when we are putting the limits of y 0 to 2, then it should be x dy as the area for horizontal strip. So we are moving a horizontal strip from 0 to 2. So x dy, firstly we have to write the circle which is little bit right side to the parabola. So basically we are going to write x right minus x left times dy. So this is going to be 2 times of integration 0 to 2. Right side curve is the circle which is root over 16 minus y square minus 2 root 3, and left side it is y square minus 4 by 8. So we have to perform this entire integration with respect to y, put the limits 0 to 2, and then we have to multiply with 2. So let's perform this integration. This is 2 times of root over 16 minus y square. Integration is basically y by 2 root over 16 minus y square, and then we have plus a square by 2. A square is 16, so a square by 2 will be 8. Sine inverse y by a, which is 4 here, and then minus 2 root 3 times of y, and then minus we have y cube by 3 into 8, 24, and then minus minus it will become plus y by 2. So this much big expression we have, where we have to substitute from 0 to 2. So at 2, y by 2, 2 by 2. So let's put the upper limit 2 here. So 2 by 2 cancelled. 16 minus 4, it will be root over 12. Then again sine inverse 2 by 4 is half. So 8 into sine inverse half is 8 into 30 degree, or pi by 6. So it is going to be 8 pi by 6, or we can say 4 pi by 3. The next one is minus 4 root 3, and then y cube is there, so it will become 8 by 24, that is minus 1 by 3, and finally y by 2 means again 1. So this entire thing is your upper limit. Now 0. So at 0, this first term will also be 0, sine inverse term is also 0, everything is becoming 0 itself, so that's not a problem. Okay, 3 in the denominator, root 12 is basically 4 root 3, so it will become 4 into 3, 12. Okay, root 12 can be written as 4 into 3 inside the root. 4 will come outside, so it will be 2, and after taking LCM 2 into 3, it will become 6. So 6 root 3 here. Then we have plus 4 pi. Then we have minus 12 root 3. Then we have minus 1, and then plus 3. So overall, I can say it is 1 by 3. I can send 2 inside after calculation. So this is 6 root 3 minus 12 root 3. It is going to be minus 6 root 3. After multiplication with 2, we will be left with minus 12 root 3, and 4 pi after multiplication with 2, it will be 8 pi. 3 minus 1 is 2. 2 into 2 will be getting 4. So we'll have 4 minus 12 root 3 plus 8 pi inside the bracket. So we can say that our answer is going to be 1 by 3. Okay, 1 by 3, 4 minus 12 root 3 plus 8 pi. So this can be seen in option number 3, 1 by 3. 4 minus 12 root 3 plus 8 pi. So C is correct. Question number 63 is, if fx is equal to integration x square plus sine square x by 1 plus x square secant square x dx and f0 is equal to 0, then f1 is equal to. So in this question, suppose I am adding 1 and subtracting 1 in the numerator, then it will be 1 plus x square plus sine square x minus 1 divided by 1 plus x square into secant square x dx. Now I will write separately by taking 1 plus x square term together and dividing it by the denominator, we will be getting 1. And after that, if you observe, we have sine square x minus 1, but I am taking minus common so that it becomes 1 minus sine square x divided by 1 plus x square. Okay, and outside we are having secant square x dx. So this becomes secant square x dx minus integration of 1 minus sine square x is basically cos square x. So cos square x into secant square x will be getting 1 divided by 1 plus x square dx. So integration of secant square is tan x and integration of 1 by 1 plus x square is tan inverse of x plus some constant c. This is the function fx, and since f0 is equal to 0, we can say tan 0 is also 0, tan inverse 0 is also 0. So c will be 0. So function is basically fx is equal to tan x minus tan inverse x. So what will be the value of f1? F1 will be tan 1 minus tan inverse 1, which is pi by 4. So tan 1 minus pi by 4, which is option D. Question number 64 is, the solution of the differential equation dy by dx equal to minus x square plus 3y square divided by 3x square plus y square, where y1 is equal to 0 is. So this type of question is basically a homogeneous differential equation where we can substitute y is equal to vx and dy by dx equal to v plus x dv by dx. Okay, so using this substitution, we can write the entire expression of dy by dx equal to minus x square plus 3. In place of y square, it will be v square x square divided by 3x square plus again y square means v square x square. So you can observe x square can be taken common and cancelled, and we are having v plus x dv by dx equal to minus of 1 plus 3v square divided by 3 plus v square. Now we can write this as x dv by dx equals to minus of 1 plus 3v square divided by 3 plus v square minus v. So I can say this is minus 1 minus 3v square minus 3v and minus v cube. Okay, after taking LCM, everything can be written like this. So denominator is 3 plus v square. This is x dv by dx. Now I can do the variable separation and write this as 3 plus v square, 3 plus v square, and from the numerator I can take minus common, so it will become 1 plus v cube. Okay, so that 1 plus v cube I can write 1 plus v whole cube basically. Okay, 1 plus v whole cube if I take minus common from the numerator, and then I am bringing it in the denominator of the left side. So this is with the dv term, and left side, if all the terms of v are there, so I can transfer x related terms to right side, which will become dx by x, and the minus which we took common on the right side, that still remains there. So we have to integrate this after variable separation. Now I can substitute 1 plus v is equal to t, from where I can also say v is equal to t minus 1. V is equal to t minus 1. So 3 plus v square will become t plus v square means t minus 1 whole square divided by 1 plus v means t cube, and in place of dv I can still write dt, and this is minus ln x plus some constant c. Now this is 3 plus t minus 1 whole square. So overall I can say that it will be integration of t square minus 2t and plus 1 and plus 3 together, it will be plus 4, and we have t cube in the denominator, so I can separate it and write like this also. So this is minus ln x plus constant c. Now this is 1 by t minus 2 by t square and plus 4 by t cube dt equal to minus ln x plus constant c. Now let us make some space for writing the next steps here, and you observe we are very near to the final answer. 1 by t integration is basically ln t, okay, and minus 2 times of 1 by t square integration is basically minus 1 by t, so it will be plus 2. Now 4 by t cube is there, so t cube will go in the numerator, so t power minus 3 integration is basically t power minus 2 divided by minus 2. So 4 divided by minus 2, it will become minus 2, and t power minus 2 I can write in the denominator also, minus 2 by t square v, and v was also y by x. So at a time I can write ln y plus 1 plus y by x plus 2 divided by 1 plus y by x minus 2 divided by 1 plus y by x whole square equal to minus ln x plus some constant c. Till here we have found. Now let's observe how to rearrange and get the final answer. If you observe ln 1 plus y by x, I can write it as ln x plus y, and one more x will be there in denominator, so I will apply the log formula, log m by n is equal to log m minus log n, and we can express like this. Second term will become 2x divided by x plus y, and last term will become minus 2x square by x plus y whole square. So if you observe right hand side also we are having one minus ln x, okay, so that minus ln x will get cancelled with the left side minus ln x. So this is minus ln x plus constant c, these terms are getting cancelled, so we are left with ln x plus y, and I will take this 2x by x plus y common, so we are left with 1 minus x by x plus y. What is 1 minus x plus x by x plus y? If you take the LCM, it will be x plus y minus x. X term will get cancelled. Only will be left with y by x plus y. So overall, it is ln x plus y plus 2xy divided by x plus y whole square, and that is equal to some constant c. Now y1 is equal to 0. So if you put x equal to 1 here, you will be getting ln 1 and y is 0, so it will be only ln 1, and this will be 2 into 0 only. Ln 1 is already 0, so we'll get constant also as 0. So which option is matching? It is ln, means log e, log with base e, x plus y plus 2xy by x plus y whole square equal to 0, which is option D. Question number 65 is the value of the integral minus pi by 4 to pi by 4 x plus pi by 4 divided by 2 minus cos 2x dx is. So let's suppose this integral from minus pi by 4 to pi by 4 x plus pi by 4 divided by 2 minus cos 2x dx is I. Okay, we have assumed this integral to be I. We have a property that if I am integrating from a to b any function fx dx, then we can also express this integral as a to b f of a plus b minus x dx. Now using this property, if we add the upper and lower limits, it will be 0. So a plus b is basically 0. So x can be replaced with minus x. So I can write this as minus pi by 4 to pi by 4 minus x plus pi by 4 divided by 2 minus. Even if I replace x with minus x for cos 2x, it will still remain cos 2x itself because cos is an even function. So we are having this term as the new integral I. Left side looks different, but still the value is I as per this property. So we have this first equation here and second equation here. If we add both of them, 1 plus 2, then we will be getting 2i is equal to minus x and plus x in the numerator, they will cancel. Pi by 4 will add up to give pi by 2, and will be left from minus pi by 4 to pi by 4 with the integral dx divided by 2 minus cos 2x. So I will be equal to pi by 4, and further if you observe the function 1 by 2 minus cos 2x is an even function, correct? So for even function I can write into 2 into 0 to pi by 4. Okay, minus pi by 4 to pi by 4 will change from 0 to pi by 4 because we have already multiplied with 2 here. And then I can also use 2 minus in place of cos 2x. uh, Let us substitute the cos 2x formula, which is 1 minus tan square x by 2, or it won't be x by 2, it will be tan square x, divided by 1 plus tan square x dx. So the integral will become I is equal to pi by 2, 0 to pi by 4. 1 plus tan square x will go to the numerator and becomes secant square x dx. But before it goes to the numerator part, it will also multiply with 2 as a part of LCM. So it will be 2 plus 2 tan square x, and this minus will also go inside. So it will make this minus tan square x as plus tan square x. So you'll be left with 3 tan square x overall. And here 2 into 1 was 2, and 2 minus 1 will be having 1 as another number. So now I can substitute tan square x as basically t square, or basically I can say tan x equal to t. I can substitute. Okay, so secant square x dx will be equal to dt. So I can say integral is 0 to pi by 4 will change to 0 to 1. Pi by 2 is still outside here, and this is dt by 1 plus 3t square, which is pi by 2. And I can write this entire thing as 1 by 1 tan inverse root 3t by 1, limits from 0 to pi by 4, which we converted already to 0 to 1 in the form of t, when we put the limits in form of t. And since this is 3t square, so coefficient of t will be root 3. I have to make uh, this 1 as root 3 in the denominator. 1 by root 3 must be there. So this is pi by 2 root 3. And if I put the value of upper and lower limits, tan inverse root 3 is basically 60 degree, which is pi by 3, and tan inverse 0 is 0 only. So this is pi square by 6 root 3, which is option number D. Question number 66 is the area of the region enclosed by the curve fx equal to maximum of sin x cos x between minus pi to pi and x axis is. So let's draw the curve of y equal to sin x as well as cos x from minus pi to pi. So sin x curve goes like this. So sin x curve is like this from 0 to pi, and for left side also it goes like this till minus pi. Cos x graph will be something like this. At 0 it will be at highest point, which is 1. In between minus pi by 2 it will be 0 somewhere, so it will drop to 0. Here also at pi by 2 it will drop to 0, right side also. Okay, and at pi it will go to minus 1. Somewhere here minus 1 will be there. This is the topmost point 1 for the curves. Again minus pi is also minus 1, so it will go like this. So this is the graph from minus pi to pi, where this is the graph of y equal to cos x, and this is the graph of y is equal to sin x. Now observe the critical points wherever they are intersecting. This is basically right side it is pi by 4, left side it is nothing but minus 3 pi by 4. Okay, it is minus 3 pi by 4 because this is minus pi by 2. This is minus pi by 2, and this is minus pi. So it is in between. This is minus 3 pi by 4. Fine. Again on right side also, if you want to understand what is happening, this is pi by 2 where cos is becoming 0. Now question is, from minus pi to pi you have to observe the maximum of this. So first thing that you observe is from minus pi to minus 3 pi by 4. Let's suppose minus pi to minus 3 pi by 4. If I check, the cos x graph is basically below and the sin x graph is above, so that is the maximum one. And since everything is below x-axis, I will have to put mod. So maximum is basically here sin x, so I will have to write sin x dx. Now from minus 3 pi by 4 to minus pi by 2, the black curve, or basically y equal to cos x, is still leading in this one. So cos x dx, now suddenly after sin x, cos x is in the lead, it is above sin x, but still we are putting mod because we are below x-axis itself. Now once we start from minus pi by 2 and we go up to pi by 4, you can observe that the graph drawn in black, which is y equal to cos x, that is the maximum. So till pi by 4 I can write it as cos x without any modulus sign. And finally after pi by 4, if I go till pi by pi only, directly you can go up to pi, then you can observe that from pi by 4 to pi, it is the sin x graph which is above cos x. So this is the entire integration that you need to perform. Now integration of sin x is basically minus cos x. So minus cos x limits I have to put from minus pi to minus 3 pi by 4. Here also I need to make sure that mod is used, and again cos x integration is sin x limits minus 3 pi by 4 to minus pi by 2, and then again for cos x integration is sin x, and this is minus pi by 2 to pi by 4, and again at last sin x is there, so integration will have minus cos x. Okay, and this is not mod, we just need to put the values. Even this is not mod, this is sin x, on which we need to put pi by 4 and minus pi by 2 as the limit values. So this is pi by 4 to pi. Only first two terms are having modulus sign to make it positive, because the area was below the x-axis. And if you put all these limits, you will be getting 4 as the answer. Question number 67 is the area of the region where y should be greater than or equal to x square and less than or equal to mod of x square minus 4, as well as y should also be greater than 1. So first of all, let us see what are the critical points here. X will be minus 2 and 2, where the term inside mod will become 0. Basically, these will turn out to be the critical points. And if we start drawing the graph, definitely when I put x equal to minus 2 and 2 value, there y will become 0. 2 square minus 4 or minus 2 whole square minus 4, both are coming out to be 0. So at these points, graph of this modulus of x square minus 4 will touch the x-axis, but after that it will be in increasing nature, right? So minus 2 and 2 is here, so after 2 if you put any value, the thing which is inside mod, that will be positive, then negative, and then positive, like that. So when it is positive, you can just remove the mod and write like x square minus 4. When it is from minus 2 to 2, you have to put a minus from your side to make the x square minus 4 term negative to positive. So it will be 4 minus x square, and again before minus 2 you can write it as it is x square minus 4. So if you observe this x square minus 4, it is going to be in increasing nature. So graph will again pick up and start increasing from here. Same way, left side also the graph will start increasing uh, for any values which is less than minus 2. So these are the points minus 2 and 2 on x-axis basically. Now what about this x square less than or equal to y? So for that, let's imagine that we are drawing y equal to x square only, y equal to x square itself. So the graph of y equal to x square will be something like this. Okay, upward parabola. Let's draw it little properly. So this is the graph for y equal to x square. Now they also gave that there is a line y equal to 1, and we also need to understand whether these critical points are 1 or something else. So let's find out also. Y is equal to x square, and if we have minus 2 to 2 curve, which is 4 minus x square, if we compare with that, we will be getting 2x square equal to 4, which means x square is equal to 2. So x value is root 2. X is root 2 and minus root 2. So this point is basically minus root 2, and this point is basically root 2. In between we have 0. So if that is the root 2, then y equal to 1 line will be passing little bit from below from that particular intersection point. So this is y equal to 1. So what is the portion that we need to find out? Now let's finalize everything. So this is our x-axis, the dotted line is the x-axis, and this is our y-axis. Okay, let's finalize the region which we have to find out. So they said y has to be greater than or equal to 1. So that is okay. We have to see above this line y equal to 1. Then they said y should be less than or equal to mod of x square minus 4, which means below this curve, that is also fine. And y should be greater than or equal to x square, which means above this parabola. Now the actual portion to be found out is this shaded portion. Okay, once we will confirm this entire area is to be found out above y equal to 1 and the bounded one. So we need to only focus on the right side first, and then we'll multiply with that area 2, because it is symmetric about y-axis. So I can write area is equal to 2 into, we'll integrate from 0 to 1, y upper minus y lower. So upper is 4 minus x square and minus y equal to 1, that is the line dx. And after 1 also we need to integrate from 1 to root 2 upper minus lower curve, which is upper curve is 4 minus x square, and then lower curve is basically x square dx. So this will give me 2 into 3 minus x square, 3 minus x square dx, 0 to 1, and this will be plus 1 to square root of 2, 4 minus 2x square dx. So let's integrate and put the limits. This will be 3x minus x cube by 3, limits will be from 0 to 1, plus 2 will also multiply with the next term, which is 4x minus 2 by 3 x cube, limits will change from 1 to root 2. Now this is 2 into upper limit, if we put, it is 3 minus 1 by 3 plus 2 times of 4 root 2 minus this will become 4 root 2 by 3 on substituting the upper limit, minus for lower limit it is 4 minus 2 by 3. So 3 into 3 9, 9 minus 1 8, 8 into 2 16 by 3 we will be getting on calculating the first term. Then this second term 3 into 4 12, 12 minus 4 is 8, 8 root 2 into 2 it is 16 root 2 by 3, and then at last this is 12 minus 2 10, 10 by 3 into 2 minus of 20 by 3 we are getting. So on solving this, overall we'll be getting 16 minus 20, 16 root 2 minus 4 by 3, which is 4 common, 4 root 2 minus 1 divided by 3. So it is option number A. Question number 68 is function fx is given as minus 2 when x value is lying from minus 2 to 0, and x minus 2 when x value is lying from 0 to 2. Okay, so hx is given as f of mod of x plus mod of f of x, then integration minus 2 to 2 h of x is equal to. So if you observe the graph of the function fx, firstly it is minus 2 before 0, okay, for any values before 0. Then it is x minus 2 from 0 to 2. So it means the graph of y equal to x minus 2 will be like this. This is y equal to x minus 2. So till x equal to 2, this is the graph that it is following. So this is the graph of fx. Now since we require f of mod of x and mod of fx, let us draw the graphs of them as well. So what is the graph of f of mod of x? For mod of x, basically we need to observe this line which was below the x-axis, y equal to x minus 2. Now whatever value, suppose x equal to 1 is giving some value on this one, same value f of minus 1 will also give, because now we are plotting for f of mod of x. So anyways the input will be same. If you put x equal to 2 or x equal to minus 2, the input to the function is going same. So it means it will be symmetric about the y-axis, and therefore it will be like this. A triangle kind of formation will be there. This is minus 2 comma 0, this is 2 comma 0. This is f of mod of x. Now what about the mod of fx? So if you observe fx function in the beginning, the value here which was minus 2, this line y equal to minus 2 will, because mod of function fx gives actually the mirror image in x-axis, similar way the y equal to x minus 2 line will be like this. So this is the other, x plus y is equal to 2, right? So we have drawn all the possible cases for different functions, I mean fx, then mod of fx, then f of mod of x. Now let us define hx function. Hx function is f of mod of x plus mod of fx. So if you observe in the region, let's suppose minus 2 to 0, because for that only our fx function was defined. So for minus 2 to 0, this line f of mod of x, if you observe, it is nothing but y is equal to minus x minus 2. So hx will be the sum of f mod of x, which is minus x minus 2, and plus, same way you observe from minus 2 to 0, the function value is taking y is equal to 2 for mod of fx, so it is coming out to be 2. And same hx value will be separate value for 0 to 2. Okay, from 0 to 2. And what is that? It is x minus 2, and then we have y equal to 2 minus x. Everything is getting cancelled, we are getting 0. And so it means the final hx graph will be something like this. For minus 2 to 0, it is y equal to minus x, which is a graph like this. And afterwards from 0 to 2, hx is 0 itself, so nothing is there. It is coinciding with x-axis. So if you integrate this from minus 2 to 2 hx dx, it is basically equal to minus 2 to 0 hx dx only, because after 0 to 2, hx function is 0 itself, so there is no area bounded there. And this area we can find without integration also, area of triangle 1 by 2, base is 2, and this height also, it goes up to y equal to 2. Therefore 1 by 2 into 2 into 2, overall we are getting answer as 2, which is option number A. Question number 69. The value of integral minus pi to pi 2y 1 plus sin y divided by 1 plus cos square y dy is. So in this integral we can write this as minus pi to pi 2y by 1 plus cos square y as one separate integral, and then we can say plus minus pi to pi 2y sin y divided by 1 plus cos square y as a separate integral. Now if you observe, the first integral is basically containing an odd function, because cos is an even function, and due to presence of y in the numerator, this is an odd function, and directly by property we can say from minus pi to pi of an odd function, this will be 0. And if this entire integral was, let's suppose, I, then we can say I is equal to this 2 we can take out, and then we can again apply the property, and one more 2 will come here, and this will be 0 to pi y sin y divided by 1 plus cos square y dy. Okay, now this is 4 times of 0 to pi y sin y by 1 plus cos square y dy. Let's suppose this is equation number 1, and again we can apply the property. In place of y we can write lower limit plus upper limit minus y, so that will give us pi minus y sin pi minus y divided by 1 plus cos square pi minus y dy. So this gives us 4 times of integral pi sin y by 1 plus cos square y, because cos pi minus y is minus cos y, but due to square it will be cos square y itself. So this entire integral can be again broken down into two different parts. This will again become integration 0 to pi. Okay, we have to write the limits as well. This is 0 to pi, and the remaining term will be y sin y divided by 1 plus cos square y. So if you observe, this second integral is basically giving us the same I if we send this 4 inside. So I can say I is equal to 4 times of 0 to pi sin y dy divided by 1 plus cos square y minus I, because that 4 will go inside, and the second integral on multiplication with 4 will give us the equation 1, which is I itself. So I can say 2I is equal to 4 pi 0 to pi and sin y dy divided by 1 plus cos square y. Now we can put cos y is equal to t here. So minus sin y dy I can substitute as dt. So I will be equal to 2 pi. Limits will change. At 0 cos 0 is 1, cos pi is minus 1, so 1 to minus 1, and sin dy in the place of sin y dy, basically I can write minus dt, and this will be 1 plus t square. So finally I can say this is minus 2 pi, and this is 1 plus t square in the denominator, so it is tan inverse of t. So on tan inverse t, if I put the limits 1 to minus 1, at minus 1 it will be minus pi by 4, and at 1 it will be pi by 4. So this is the answer for this tan inverse portion. So that is minus pi by 2 overall, and already we had minus 2 pi here. So it is basically simply pi square, which is option number A. Question number 70 is integral 0 to pi by 4 cos square x sin square x dx divided by cos cube x, and here it should be a plus sign between cos cube x and sin cube x. So this is plus sin cube x whole square. So to solve this integral, let us divide numerator and denominator both by cos power 6. So one cos square will be getting cancelled. The another cos square just below sin square will make it tan square x, and cos square will be remaining in the denominator, that will become secant square x. So after dividing with cos power 6, this will be cos square will get cancelled, sin square by cos square will give us tan square, and one more cos square x will become secant square x dx. In the denominator, since we are dividing by cos power 6, when it goes inside the bracket, it will be cos cube only. So I can directly write 1 plus tan cube x square. Now let us substitute 1 plus tan cube x is equal to some parameter t. So when we put the limits, now it will be at 0 tan 0 is 0, so it will be 1. At pi by 4 tan pi by 4 is 1, so this upper limit will be 2. And since we have substituted 1 plus tan cube x equal to t, after differentiation we can write 3 tan square x. This is the differentiation of this power, and then tan x differentiation will be secant square x dx is equal to dt. So if I write 1 by 3 here, then I can introduce a 3 in the numerator, and along with this tan square secant square x dx, everything will become dt, and denominator will become t square. It means 1 by 3, the integration of 1 by t square is basically t power minus 1 by minus 1. So it is actually minus 1 by 3 1 by t, and limits from 1 to 2. So minus 1 by 3 limits, if I put, it will be 1 by 2 minus 1, which is minus half. Overall I will be getting 1 by 6, which is option C. Question number 71 is the equation of a curve whose slope at any point is thrice its abscissa value, which passes through minus 1 minus 3, is 2y is equal to lambda x square minus 3, then the value of lambda must be. So in this question, we know that slope at any point can be given by dy by dx, and it is thrice of the x coordinate. So this is basically a differential equation format. So I can say dy is equal to 3x dx, a normal variable separation question. If we integrate both sides, it will be y is equal to 3x square by 3 plus some constant c. Now since it is passing from minus 1 minus 3, I can say y coordinate minus 3, and 3 will get cancelled. Here it will be minus 1 square plus c. Okay, so from here I can say it is minus 1 equal to 1 plus c. So I will get the constant value, or the arbitrary constant value here, as minus 4. So our actual equation of curve will be y is equal to x square minus 4 by 2 plus integration constant c. Now in this equation, since that is already given in the question that y coordinate is minus 3 when x coordinate is minus 1, we can say 3 by 2 minus 1 whole square plus c. So it is minus 3, and minus 3 by 2, that is equal to c. So it is minus 9 by 2, that is the value of c. So I can say that the equation of the curve is actually 3 by 2x square and minus 9 by 2, which basically means 2y is equal to 3x square minus 9. So I can take 3 common and write here x square minus 3. So in place of lambda, you can see we are having the number 3. So answer for this question is 3. Question number 72 is we have an fx integral from 0 to x dt divided by ft whole square. Okay, so if we try to find out f dash of x from here, we have to put this x in place of t. So that is the first thing that we do. Now f dash of x will be 1 by f of x whole square. This is the first thing. Whenever differentiation of definite integration is to be required, you put the upper limit in place of t, then differentiate the upper limit, minus same thing with the lower limit. So since lower limit is already 0, we will be getting f dash of x as 1 by fx whole square. So from here I can also say that this is dy by dx equal to 1 by y square. So I can write this as y square dy is equal to dx. Both sides if I integrate, I will be getting y cube by 3 plus some constant, that is the value of x. So this will give y cube by 3 is equal to x plus c, or I can write y cube as 3x plus 3c, which gives us y is equal to cube root of 3x plus 3c. Now another information given is 0 to 2 dt by ft square is basically cube root of 6. When I say 0 to 2, it means the upper limit is 2, and if you compare with this function, it means that the information given is nothing but f2. This is the value of f2. So I can say that at x is equal to 2, the y value is cube root of 6. So I can use this one, our already obtained equation. So it is cube root of 6 equal to cube root of 3 into 6. So this was the value at 2. So I can put in place of x as 2, and then this is 3c. So you can observe, since both side inside this cube root 6 must be there, already 3 into 2 is giving us the value 6. So definitely c will be equal to 0. Therefore our actual curve is cube root of 3x. So f9 they are asking. So f9 will be equal to cube root of 3 into 9, which is 27 cube root, and that answer is again 3. Question number 73. The order of a differential equation representing the family of curves y square is equal to 2cx plus root over c, where c is a positive parameter, is. So let's differentiate this equation. We will be having 2y, then dy by dx, that is equal to 2c, and the differentiation of x is 1, root c differentiation is 0. So 2 and 2 we can cancel from both sides. I can write this as y dash, that is equal to c. Now I will be using this equation itself to remove this positive parameter. I can write this as y square equal to 2 times of c means y dash, and inside the bracket I can write x plus root over c means again root over y dash. This as y square is equal to 2xy y dash plus 2y dash root over y dash. So it is y square minus 2xy y dash whole square, which will give us 4 times of y cube and y. The order is 1 only because we are having the highest order derivative as first derivative, dy by dx or y dash. There is no y double dash or triple dash, and degree will be basically 3 here. But they are asking the order of the differential equation, so correct answer is 1. Question number 74 is let function r to r be a continuous function such that fx plus 1 is equal to 2. Then integration or integral I1, which is 0 to 8 fx dx, and I2 is equal to minus 1 to 3 fx dx is given, and they are asking I1 plus 2 I2 value. So this is based on the periodic function properties. If you observe this relation for the function, let's write this as f of x plus 1 equal to 2. Let's write this equation for x equal to x plus 2 basically. So in place of x, I'm going to replace it with x plus 2. So this is f of x plus 2. So this functional relation that is given to us, let us write it for fx plus 1 equal to 2 minus fx. Okay. Now if I replace x with x plus 1, this will become f of x plus 2, that is equal to 2 minus f of x plus 1. Now already we had one equation given in the question, so from there I can write fx plus 1 is equal to 2 minus fx. So this will become 2 minus of 2 minus fx. So if we open these brackets, we will be again getting back our original function. It means when I replaced x with x plus 1, it became f of x plus 2, and that is giving back the function. And according to the property, whenever fx plus t gives us a function fx, the same function where t is the minimum positive value, then that is called the period of the function. So here I can say the period of this function is basically 2. Now in I1 I can definitely write this as 0 into 2 into 4 fx. You can say it is 4 times the integration 0 to 2 fx dx, right? So let's suppose this is equation 1, and now if you observe I2 is from minus 1 to 3 fx dx. If we replace x with x plus 1 here, okay, x with x plus 1, then dx will not change, it will be just change in the limits, it will be from 0 to 4, and this will be fx plus 1 dx. All right, so now let us do some manipulation to get the I1 plus I2 2i2 value. So we have I1 and I2 ready with us, we know the period of the function. Now let's write down this integral I2 as 0 to 4. In place of fx plus 1, I can write 2 minus fx dx. So this will give 0 to 4 integration 2 dx minus 0 to 4. We have fx dx also. So I2 value is basically, this is 2 into 4 and this is minus. If you observe from this equation, I can write 0 to 2 integration also by writing this as 2 into 0 to 2 fx dx. Okay. So what is this entire expression 0 to 2 integration fx dx? From here I can say it is basically I1 by 4. Okay. So I will substitute that value here. It will be 8 minus 2 into I1 by 4, which is basically I1 by 2. So I2 value is 8 minus I1 by 2. So I can say 2I2 will be 16 minus I1, and therefore minus I1 will come to the left side. It will be I1 plus 2I2 equal to 16. So 16 is the right answer for this question. Question number 75 is, let alpha is the area of the larger region bounded by the curve y square equal to 8x and lines y equal to x and x equal to 2, which lies in the first quadrant. So let us see the diagram first. Let us draw the curves and then we will be knowing which area it is talking about. So y square equal to 8x, that graph is basically symmetrical about x-axis, and then we have line y equal to x. So let us draw the line y equal to x. It is passing from the origin. Okay, and then we have x equal to 2. So x equal to, so if we see the intersection point of this line and the parabola by putting y equal to x, it will be basically x square equal to 8x. Okay, so we'll be getting either 0 or 8. So already they are intersecting at origin, which is 0 0, and one other value we have got is 8. So this is basically 8 comma 8, and x equal to 2 will be much before here. In the beginning x equal to 2. So you can see there are two different areas. One is this small area, and then the other one is the larger area enclosed between the line and parabola, this one. So alpha is the area of this larger region bounded by the curve and the line y equal to x and x equal to 2, and it is also lying in the first quadrant. So conditions are satisfied. So what we need to do now, if we observe, to find out this larger area, we can say integration from 2 to 8, okay, y upper minus y lower curve. So what is the upper curve? It is y square equal to 8x. So if I want to write y dx, it will be root over 8x minus the lower curve, which is y equal to x. So this is y upper minus y lower dx. Now I can say this is root over 8. Root x integration is x power 3 by 2. So it will be divided by 3 by 2, and limits I can put from 2 to 8, and this will be minus x square by 2. Again 2 to 8 I can put the limits. So this is 2 root over 8 by 3. After putting the limits, it will be 8 power 3 by 2 minus 2 power 3 by 2, and then we have minus 8 square minus 2 square divided by 2. So let's calculate the final answer. This is 2 root over 8 by 3, and this is root of 8 to the power 3. So it is going to be 8 root 8 minus, again it is root of 2 cube. So it is 2 root 2 minus 64 minus 4, 60. 60 by 2 is 30. This is the alpha value. Now let's multiply everything. So here we'll be getting 8 into 8, 64 into 2, 128 by 3 minus, again here will be, it will be 2 into 2, 4, root over 16 is again 4, so 4 into 4, 16 by 3 minus 30. So it will be 112 by 3, 112 by 3 minus 30. That is the alpha value we are getting. So they are asking 3 alpha. So 3 alpha will be 112 minus 90. Okay, if you multiply with 3 in the final last equation that we have got here, we'll be getting 112 minus 90, which is basically 22. So 22 is the right answer for this question. So that's it. Thank you. Hope you have understood the discussion.